Hello student, today we will perform the test which is known as total leukocyte count test या WBC test या white blood cell count test. ठीक है. For this test we require the apparatus required for WBC count. First is the improved Nuba chamber, second is the WBC pipette, third is the WBC diluting fluid that is known as Turk's fluid, fourth is the compound microscope, fifth is the cover slip, sixth is the pricking apparatus, and then lancet, cotton and spirit. These are the apparatus which we required to perform the WBC count. Then second one is the identification of WBC pipette. How we will identify the WBC pipette. There are some identification marks on the WBC pipettes. First one, the WBC pipette is from this side. The bulb is of the WBC pipette is smaller as compared to RBC pipette. In this pipette, white bead are present, and pipette red bead is present. The mouthpiece is in white color in WBC pipette, and the mouthpiece in RBC pipette is red in color. There are some marking on the WBC pipette. These marking is 0.5, 1 and 11. Then third one is the composition of the Turk's fluid. In the 100 ml of total WBC fluid, there is a composition and functions of diluting fluid. First, we require glacial acetic acid. This amount of glacial acetic acid is 3 ml. Third one is a gentian violet. The amount of gentian violet is 1 ml and distilled water is 100 ml. ठीक है. What is the function of glacial acetic acid? Glacial acetic acid help in destroy the membrane of RBCs and platelets. Gentian violet to strain nuclei of WBCs. Gentian violet help in to strain the nuclei of WBC. Distilled water is required as a solvent. ठीक है. After that we see the apparatus. This is the improved Nuba chamber. This is improved Nuba chamber. This is a WBC pipette. The mouthpiece, bulb and the readings are present. This is the stem part of the WBC pipette. These are the instruments which we required to perform the practical. ठीक है. The instrument required to perform this experiment is, first we need a microscope. This is a compound microscope. Then second one is a Nuba's chamber. This is a Nuba's chamber. Third one is a cover slip. Fourth is a WBC pipette and Turk's fluid. This is WBC fluid which is known as the Turk's fluid and cotton. And then second, how we perform this experiment we see. First we prick our finger. After that after pricking the finger, we should take blood up to the 0.5 mark. After pricking blood, we take Turk's fluid up to the 0.11. After this, taking the fluid, we mix this fluid and the blood in a normal proportion so that the fluid and blood should mix. We put this pipette in our palms and mix like this. After mixing the blood, we should discard 1 drop of solution from this stem part. After that, we take this Nuba chamber and put this cover slip on the Nuba's chamber. After discarding the 1 or 2 drops of solution, we should put this pipette on the Newbar's chamber to charge this chamber. For charging the chamber, we should know about the steps to charge this chamber. First, we should not overcharge this chamber. We should take equal proportion of solution to charge this chamber. We should put this pipette in that way, and with the help of this action, the Newbar's chamber from both sides, we charge this Newbar chamber. The Newbar chamber is charged. After charging this Newbar chamber, we put this Newbar chamber under the microscope and we focus this Newbar chamber on 10x. The low power magnification, we should focus this Newbar's chamber. We put this on 10x. After that, we focus the Newbar chambers on 10x. After focusing on this Newbar's chamber, we should get this type of image. This type of image we get in the microscope. This is a one square of WBCs. Like this, there are also four square of WBCs are also present. After counting one square, we should also count the second square, third square and fourth square in the same way. In the first, we have to calculate the first square. After that, this will denoted as a n. And this chamber is denoted as the n1, and second chamber is denoted as n2, and third is denoted as n3, and fourth one is denoted as n4. Like this, we should denote the four chambers of WBCs. Then we calculate the overall WBCs in these chambers, and we calculate like this: n1, n2, n3, n4. We should calculate these four chambers in this way. N is equals to n1, n2, n3 and n4. After this, we should first before we check these chambers, we should know about some rules to how to calculate the WBC chambers. In this border and this border, at this border and this border, there are some WBC cells are present. These borders should be counted in a WBC counting. WBC counting, these borders are count, but these two borders are not count. Same thing is required in first, second, third and fourth. Upper border and the left border of the square should be counted, but the lower border and the right border does not count in a WBC chamber. After that, the calculation of dilution factor. How to calculate the dilution factor? We have 0.5 part of the blood and 10.5. This is the 11.1.5 part. We should discard from the stem part. So there is 0.5% of blood and 10.5% of the dilution solution या mixture we have in the pipette. So 1.0 part of the fluid present in the stem pipette do not mix with the blood and it should be discarded. So 0.5 part of the blood mix with 9.5 part of the fluid to make it 10 parts. Therefore dilution factor is, we can calculate the dilution factor is 10 by 0.5. 10 by 0.5 means the dilution factor is 20 times. The effective dilution factor is 20 times. After that, we should know we should know about the calculation of Newbar's chamber. First, length of the WBC, 1 square of the WBC. Length of 1 square of WBC is 1 mm and width of the WBC is 1 mm. Length is 1 mm and depth is 1 mm. So volume of 1 square we should have to count. Depth of the counting chamber. So depth of the counting chamber is 0.1 mm or 1 by 10 mm. ठीक है. Volume of 1 square is area into, how to calculate the volume? Volume is equals to area into distance. Distance होता है ना, area into distance, volume. ठीक है, एरिया इंटू डिस्टेंस. तो एरिया इज 1 इंटू 0.1. तो एरिया इज कैलकुलेटेड एज 0.1 mm3. Okay, after that volume of, like we calculate the volume of 1 square, that's in this way we should calculate the volume of 4 square also. 4 into 0.1 is equals to 0.4 milli cubic mm. Cubic mm. ठीक है. If number of cell counted in 4 square is equals to n, तो 0.4 cubic mm of blood will count n. तो number of cells, dilution factor of the blood, 1 mm of cube of blood will be, dilution factor is 20 times, and 1 mm of 1 cubic mm of blood cell have n into 50 cells. Like according to this we we also calculated directly this with the help of formula. Formula is for it is number of cells counted multiplied by dilution factor upon area counted into depth of the fluid. The number of cells is n, dilution factor 20, and area counted is 4 into 1 square mm into depth of the fluid is 1 square mm into 0.1 mm. So dilution factor is, we should calculate the dilution factor. So dilution factor is n into 20. N is for number of cell counted, we should multiply it with 50. This is all about the WBC TLC practical. So there are some disease related to it. So first disease is the leucocytosis. The term cytosis means the number of cell count is more, and second is the leukopenia. Leukopenia means like the WBC count should be less. If the WBC count is more than 10,000 cubic mm, in which condition it should be? Like first condition is a bacterial infections, second is a viral infection, third is a parasitic infection, and fourth is a severe hemorrhage condition, and fifth is a leukemia condition. Leukopenia means the blood cell count is less than 4,000 cubic mm. Certain viral infections, bacterial infection, tuberculosis, rheumatoid arthritis, parasitic infection, anemia, in some cases of leukemia, aplastic, megaloblastic anemia, iron deficiency anemia, all about these the WBC practical. Normal count at the time of birth. At the time of birth, the normal count is 10,000 to 25,000 per cubic mm, and in 1 to 3 years it is 6,000 to 18,000, and in 4 to 6 years it is 6,000 to 15,000 per cubic mm. In adult it is 4,000 to 10,000 per cubic mm.